Okay, Vinash, let's continue the demo. We'll take a short demo, a brief intro on what networking is and what IP addresses are today, since Liam has joined as well. I'm not sure if he can hear me or not. Okay, but still, since you have joined today, and since there's one more student as well, they might at least refer back to the recordings. Okay, so yeah, before we get started, a quick formal introduction on my name is Mohammed Shoaib. I'm a cybersecurity trainer certified from EC Council, one of the leading organizations for trainings and certifications in the domain of cybersecurity. And the course that we're going to go through in the upcoming days is Certified Ethical Hacking version 12, a course which is fundamentally chosen for getting started in cybersecurity. Okay, and one of the prerequisite topics for this is networking fundamentals. We need to understand how do computers or devices communicate with each other, and what is this concept of IP addresses, again, which is very important for cybersecurity. Okay, so when you talk about networking fundamentals, there are three important definitions to know. Firstly, there is a concept of what networks are, or what networking is, what networks are, and what hosts are. So when you talk about networking, this is the practice of connecting information devices with each other to share resources or info. Okay, now these devices could be anything. They could be as small as a mobile phone to as big as a web application server or a database or cloud network. Okay, the connectivity of each of these devices to transmit data to each other is called as networking. Okay. Now, when you talk about networks, that collection of those interconnected devices itself is called as a network. So in your home network, in your home Wi-Fi network, you have your Wi-Fi router, you have your phone, your laptop, your smartwatches, etc., connected to each other. So that becomes your local network, a group of devices communicating with each other. And in that group, each of these devices is called as a host. So host refers to any individual device connected to that network which can transmit or receive data. Again, as an example, it can be your computer, your printer, your router, your mobile phone, your smartwatch, your IP cameras, etc., etc. Okay. Now, just like how we humans have names to address each other, to identify each other, these devices also have names, and that name is called as an IP address, Internet Protocol Address. This was built by the US military in the late 1950s or so. And again, there were multiple versions of it as well, IP version 1, IP version 2, IP version 3, etc. They were quite experimental. What successfully worked out was IPv4, Internet Protocol version 4. Okay, and we're still using that IPv4 address even in today's world. Okay, to define what an IP address is, each host on the network has a unique identifier, and that name or identifier is known as an IP address. And this IP address allows for communication to occur between these devices, because now they have a method of identifying each system on the network. Okay, and this IPv4 address has a few important properties to it. First property of an IPv4 address is it's a 32-bit address. Now what I mean by 32-bit is that each bit is either a value of 0 or 1, the smallest data value a computer or any information system can store. Okay, and your IPv4 address is a combination of 32 bits as such, 32 zeros and ones as such. Okay. And this 32-bit address again is divided in 4 equal parts, okay, of 8 bits each. Okay, so 8 bits again, that each 8-bit portion again is called as an octet, and each octet is divided by a dot symbol. So if we have to look at a typical IP address, this is what it would look like in the language of zeros and ones. And this language of zeros and ones is also commonly known as the binary language. Okay, so if you notice over here, there are 8 bits here, and then there's a dot, then another 8 bits here, and then a dot, another 8 bits here, and then a dot, and another 8 bits here, and in total 32 bits. Now this is what the computer easily understands, this language of zeros and ones. But we humans have a tough time understanding this language. What we regularly use are decimal numbers, numbers from 0 to 9 instead. Okay, so this number 11000000 can actually be converted to a number like 192 in human readable numbers. Okay. This number 10101000 is actually equal to 168. All zeros is equal to 0, and 00001010 is actually equal to 10. Now don't get confused how we got these values. I'm going to explain that now. Okay. But any questions or doubts up to this point? Liam, Avinash?
No, sir.
Right. So let's talk about how do you convert any number from binary to a decimal value. Okay. So let's take this example of this number here, 10101010. Okay. And if you had to convert this number from binary to decimal, there are 2 simple rules for it. Rule number 1 is you write down the values of 2 power 0 all the way up to 2 power 7 from right to left. So under the rightmost bit you have 2 power 0, then you have 2 power 1, then you have 2 power 2, then you have 2 power 3, then you have 2 power 4, then 2 power 5, then 2 power 6, and 2 power 7. If you have a question why specifically 2 power, because this is a binary number, you only have two possibilities, either a 0 or a 1. And once you've written down those values now, all you have to do is multiply the lower number with the top bit and keep on adding it till the end. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. Okay. Now, if you keep on adding all these values and multiplying them, you get the final decimal answer, or the actual binary. The binary number gets converted to the decimal number. So if we calculate this now, so let me write down the values of 2 power numbers first. 2 power 0 is nothing but 1. So anything to the power 0 is always equal to 1. It's a mathematical rule. 2 power 1 is 2 itself. 2 power 2 is 2 into 2, that's 4. 2 power 3 is 2 into 2 into 2, 3 times, that's 8. 2 power 4 is 2 into 2 into 2 into 2, 4 times, that's 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. So now let's start calculating. 2 power 0 into 0. 2 power 0 is 1. So 1 into 0, that's simply 0 again. 2 power 1 into 1. 2 power 1 is 2. So 2 into 1, that's 2. 2 power 2 into 0, 0. 2 power 3 into 1, 8. 2 power 4 into 0, 0. 2 power 5 into 1, 32. 2 power 6 into 0, 0. And 2 power 7 into 1, 128. And if you add all this up, 128 plus 32 plus 8 plus 2, you get the number 170. So 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So this number 170 in human readable language is represented as 10101010 in computer understandable language, or in binary language. Okay, so when the computer reads this number in the form of high and low frequencies, high, low, high, low, high, low, high, low, it understands that this number is 170 in human readable language. Okay, is that clear? Avinash, Liam?
Yes, sir.
Right. If this is clear, I have a few examples here. And if you have a pen and a paper beside you guys, can you try and calculate and give me the answer for these numbers? 0, 1, 0, 1, 0, 1, 0, 1, and all ones. Two different binary numbers here. So if you have a pen and a paper beside you, take your time, no rush. Calculate the binary numbers equivalent to the decimal numbers.
So for the example one, is the answer 255, sir?
Example one, the top one or the bottom one, Avinash?
Top one, sir.
255, are you sure?
01010101.
No, it is not 255. 2 power 0 into 1 plus 2 power 1 into 0 plus 2 power 2 into 1 plus 2 power 3 into 0. So that way, I don't think you would get 255 for that. Okay, no worries. Let me explain. So again, nothing to worry. Maybe minor calculation error here or there. But again, if we try to calculate this out, so 2 power 0 into 1. Okay, that is 1. Plus 2 power 1 into 0, that's 0 again. 2 power 2 into 1, that's 4. 2 power 3 into 0, 0. 2 power 4 into 1, that's 16. 2 power 5 into 0, that's 0. 2 power 6 into 1, that's 64. And 2 power 7 into 0, that's 0. So if you add all this up, 64 plus 16, that's 80. 80 plus 4, 84. 84 plus 1, that's 85. So this is not 255, it's 85 instead. Maybe minor calculation error somewhere here or there, Avinash, but I hope it's clear now how we got this number, 85. And
So
then
can
you
you explain once again, sir?
Sorry.
Can you explain once again, sir, if you don't mind?
Yeah, again, as mentioned, you multiply the lower number with the top bit, right? 2 power 0 into 1 plus 2 power 1 into 0 plus 2 power 2 into 1 plus 2 power 3 into 0 plus 2 power 4 into 1 plus 2 power 5 into 0 plus 2 power 6 into 1 plus 2 power 7 into 0. So if you multiply and add 2 power 0 into 1, that's 1. 2 power 1 into 0, that's 0. 2 power 2 into 1, that's 4. 2 power 3 into 0, 2 power 3 is 8. 8 into 0, that's simply 0. 2 power 4 into 1, that's 60. 2 power 5 into 0, 0. 2 power 6 into 1, 64. 2 power 7 into 0, 0. So if you add all this up, 64 plus 16 plus 4 plus 1, you get the number 85, right? Is that clear, Avinash? Hello. Still a bit unclear by any chance? If it is unclear, let me explain one more example then. This next one, example 2. Okay, so when you put all ones here, so when you put 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 into 1 plus 2 power 3 into 1 plus 2 power 4 into 1 plus 2 power 5 into 1 plus 2 power 6 into 1 plus 2 power 7 into 1. So if you add all that up now, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you get the number 255 here. Okay, for example 2, the answer is 255. Okay, and the reason I'm explaining all of this, the binary to decimal conversions, is because we get to know the range of IPs from this method. So if I had to get the first IP, all I have to do is put all zeros everywhere. And if I had to get the last IP, I have to put all ones everywhere. So when I put all zeros, you simply get the first IP as 0.0.0.0. And if I had to get the last IP, all I have to do is put all ones everywhere, where you get the last IP as 255.255.255.255. Okay, so this makes us understand that no matter what IP address you take in the IPv4 range, it will never exceed the number 255, because again, when you put all ones, the maximum number you can convert from binary to decimal is 255 itself in that 8 bits of length. Okay, so you can never have IP addresses in the negatives below 0 or in the positives above 255. Whatever IPs you have, they would only range from 0000 to 255, 255, 255, 255. Okay. And if someone were to ask you how many IPs do you have in total, again, since you have 32 bits here, and in each bit there are 2 possibilities. So the total number of IPs would be 2 to the power 32. And that would give you a number of 4.3 billion IP addresses. So when these IP addresses were invented, you had a total of 4.3 billion IPs in total. So back in 1950s, 4.3 billion was a huge number. But fast forward to 2024, the population itself today is 8 billion people, I suppose, and each person can have multiple devices again. So in such a manner, 4.3 billion IPs would have nowhere been sufficient. So that is why these IPs again are divided in a lot of categories. Okay, there's something called as classes. Okay, and then there's something called as public and private IPs. So there's class A, class B, class C, class D, and class E. And again, in each class, you have two subcategories again: public and private, public and private, public and private. Class B and class C don't have any private IPs in them; they're all public itself. Okay. So don't worry what these classes are, what these public and private IPs are. We'll be talking about these in the upcoming sessions anyhow. Okay. So again, as mentioned, we need to form up a batch. We need to take a couple more demos so there's other students available as well. So we can have a small Q&A session now, just in case, to clarify your questions also. Hi, FHYX. Can you hear me? Am I audible? Can you just type random words on the keyboard for your name registration? Hi, FH. Can you hear me? Okay. Avinash, I hope you can hear me though. I hope it's clear how we convert binary numbers to decimal numbers. Any questions on that? Okay, assuming no questions. So yeah, again, as mentioned, guys, we'll be forming up a new batch. We'll be taking up a couple more demos, and we'll arrange a batch accordingly. And we'll see from Monday onwards, we'll be starting this same sessions again. Okay. So yeah, nothing further for our session today, guys. Let's exit the session and continue in the next session. Okay. Bye bye.